Okay guys, today we are going to talk about geometric sequences. Geometric sequences are sequences where from one term to the next term you are multiplying by a common number. So you can see this initial sequence 4 to 8 to 16. It seems pretty obvious that this is times 2 times 2. So the next one in this would be 16 times 2, which is 32, and then 32 times 2, which is 64. So let's come over here and kind of look at the whole pattern here. Okay, we'll try and do the same thing that we did before. So where this is the term number value of that term. With the first term, let's get rid of that. The first term is a 1. The second term is 2, the third term is 3, but the value, the first term of the value of the first term was a 4, the value of the second term was 8, the value of the third term was 16, so the fourth term is 32, the fifth term is 64, etc. And let's think again about how we got from one to the other. So to get from here to here, we times by 2. So this 8 is actually 4 times 2. Get from here to here, we times by 2. And so this was actually 4 times 2 times the second 2, or you could think of that as 4 times 2 squared. So here we times 2 again. And so this one would have been the initial 4 times 2 to the third power, because we've times by 2 3 times. Here we times 2 again, so this one would be the initial, and then we've multiplied 4 times, okay? So if we really look at what we've just come here, let's see if I change this to this color. Okay, here this is just 2 to the first power. Here, this is to the second power, to the third power. And again, how do those, what the power that we're raising, how they relate to the term number? So when I'm on the second term, I'm only raising that 2 to the first power. When I'm on the third term, I'm raising that 2 to the second power. Fourth term, I'm raising it to the third power. Fifth term, I'm raising it to the fourth power. So if I were to come down here and think of like, what is the nth term? Well, this would start with the 4 times 2 raised to, well, I'm not going to raise it to 2n times, but it's always been 1 less. So raised to the n minus 1. Okay? As a general formula, so first of all, some definitions here. The 2, the number that we're multiplying by every time, is what we refer to as common ratio. That was probably not a good job of circling that. Okay? We call it a ratio because if we take any term and divide it by its previous term, 2. Take any term, divide it by its previous term, we get 2. Any term divided by its previous term, we get that ratio. A fraction is just a ratio. So this 2, that 2, that 2, they're all the same ratio. That number is in common, so we refer to it as a common ratio. So our answer here, R, is the letter we're using for common ratio. That's 2. So now calculate the 20th term. Well, this would be really annoying, having to go to 4, 8, 16, 32, 64, and go all the way out to the 20th term. So there's got to be a formula we can use. Well, the general formula here, we can kind of see it down here. The nth term, u sub n, would equal the first term, which is the 4, times the 2 represented the common ratio raised to the n minus 1 power. So there is our general formula. So I'm going to come back up here. Calculate the 20th term of this sequence. So that means I want u sub 20. Okay? Again, that's going to equal the first term times the common ratio raised to the n minus 1. So what is that first term? We don't, or the 20th term, we don't know. We know the first term was a 4. We know the common ratio was 2, and we're going to raise that to 20 minus 1. So this is 4 times 2 to the 19th power, which you would just go to your calculator and type that in, and you get 97,152. So there is our 20th term. Okay? There's really only 2 things you need to know in order to work out a geometric sequence. You need to know what's the first term. You need to know what its common ratio. Sometimes you'll have to work backwards from that first term. And so I'm going to scroll down and do one more here. I'm going to do number 5 just because it's got a little more going on here. In number 5, the first term is 18, or the second term is 18. The fourth term is 81 over 2. All the terms in the sequence are positive because the common ratio can be negative. So we could multiply by a negative number. If I were to come back up here to the top, you know, maybe this thing could have looked something like 4, I hit erase, 4 comma negative 8 comma 16 negative 32 comma positive 64 comma negative 120. In that case, my common ratio would have been negative 2 each time. Okay, so we don't always know, if we only know a couple of terms, whether or not the thing is positive or negative, that common ratio. So sometimes we have to say that. Okay, so I'm going to scroll down here to number 5, and let's kind of think about what our table would look like over here. So my first term I don't know. My second term I know is 18. My third term I don't know. My fourth term I know is 81 over 2. But here's what I do know. In order to get from whatever the first term to the second term is, bring this back into a different color here. In order to get from there to there, I had to time by the common ratio. From here to here, I had to times by the common ratio. From this one to this one, I had to time by the common ratio. So if I know how many terms it is from the second term to the fourth term, that's 2 terms, that means I had to multiply by this common ratio twice to get from 18 to 81 over 2. That helps me solve for the common ratio. So I can make this that 18 times r times a second r is going to give me 81 over 2. Or I could write this as 18 times r squared equals 81 over 2. So I could solve this, divide by 18, divide by 18. On your calculator, just type that in exactly the way you see it. 81 divided by 2 divided by 18. This would be r squared equals, as a decimal, 0.25, but it's probably easier to think of it as a fraction, which you can just on your calculator have it turn it into a, figure out what r is. Square root. Square root. Remember, when you take the square root of a fraction, all you have to do is take the square root of the top. So there's my common ratio. There's my answer. 3 over 2 is r. Okay? Now, I still need to know what the 8th term in the sequence is. I probably would like to know what the first term in the sequence is. So in order to get from, to go in reverse, instead of multiplying, to go this way, I would divide by 3/2. So my first term, if I wanted to do it this way, could be 18, well, the first term would be, 18 divided by 3/2. Remember, dividing by a fraction is the same thing as multiplying by its reciprocal. 18 divided by 3 is 6 times 2 would be 12. So that means my first term was 12. I could do the same thing here. This would actually be 27. Okay? So, in order to figure out my 8th term in the sequence, I can come back to my original formula here, u sub 8, first term, times the common ratio raised to the n minus 1. So this would be 12 times 3/2 raised to 8 minus 1. So this is 12 times 3/2 to the 7th power. And I have no expectation that you're doing that in your head. You can do it on a calculator. This thing ends up being 205.03125, or you can write it as a decimal, which is 6 divided by 32. And no, I did not just do that in my head. I looked that up. Okay? I'm going to make a little bit of space for myself over here. I think this just worked. And I'm just going to show you just another way you could have done this maybe a little bit differently, and we never would have even had to figure out the first term. Okay? So, other way, heck, I could have started with the fourth term here and said, okay, if I start with the fourth term, well, how multiply by our common ratio to get to the 8th term? Well, I do it once to get the 5th, second time to get the 6th, a third time to get the 7th, a fourth time to get to the 8th. Okay, and I could have figured that out just by simply doing 8 minus 4. So I started with the fourth term, and I'm trying to get the 8th. So 8 minus 4 is what goes right there. That gives me 4 terms. So 81 over 2 times 3/2 to the, and that should end up equaling the same thing that we had there. Okay? That's geometric sequences. Your job is to do the rest of the problems on the page. So you got 6 problems to go, and ask questions, reach out with questions as you need it.